Good morning, everyone. Welcome back. So in the last video, we had determined that mu, d, and um is the three candidate for the primary quantities. Now let's go ahead and find all these dimensionless group. Okay, so in the past video, we have showed that rho, and d are a good fit for primary quantities, right? So now we can find, let's find all of the dimensionless group. Okay, how do we do that? Now, first of all, we have to know how many dimensionless group we have. Okay, so if you recall that we are given the shear stress is the function of x, d, rho, mu, and epsilon, right? So just like, y, so you can say from here, you can say that there exists a function of tau w, x, d, rho, mu, epsilon equal 0. Why do I say that? What does it mean? Like, for example, if you have so for example, like let's say you have your y equal to x cubed plus 2x, right? So you can say that y minus x cubed minus 2x equals 0, and if you name all this chi of xy, you can say chi of xy equals 0. So similarly with this, so from tau, from the shear stress, the function of all these variables, there's exists a function that cover all of them, and that function is always equal to 0. So there's a very cool scientist. He invented something called the Buckingham pi theorem. So according to the Buckingham, like the police, Buckingham pi theorem, what does it say? It say the number of dimensionless group, how do you calculate that, is equal to the number of total variable, minus the number of fundamental dimension. So how many total variables we have? All the total variables we have is in the f function right here. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 total variables. Okay. How many fundamental dimension we have? Remember, we have mass, length, and time. So it's 3. So we have 4 dimensionless group in total. Okay, wonderful. So we know that we have 4 dimensionless group. Now, how can we find the 4 of them? So a dimensionless group, a dimensionless number, it has the denominator. Now, let me write, this is numerator, and this is denominator. So what is the numerator can be in this case? Numerator. So the numerator is any variable, but the primary variable. So So we have 7 variable in totals, right? Y'all remember tau w, x, d, um, rho, mu, and epsilon. Now, according to the definition, the numerator is the variable, but except the primary quantities. So the primary quantity is the one we have determined in the previous video. So it's So let me draw a circle over it. So we have d, and mu, right? Is our primary quantities. So our denominator can be tau w, x, rho, and epsilon. Okay, so let me write. So in this case, it consists of tau w, rho, epsilon, and I think t, right? Let me see. Oh, and x. Okay, so and how about denominator? The denominator. So our denominator is power multiplication of the primary variables. So what does it mean? For example, it can be, so our primary variable is mu, d, right? So what does that mean by power multiplication? So you just power it to a number, a1, b1, c1, and then later I will find them, or it can be mu to power a2, b2 times d to power c2. Okay, all that. It's just as long as it's the power multiplication of the primary quantity. Let me make it clear. This should be quantities. Right? Quantities. Yeah, quantities. Okay. Okay, so we know the numerator and denominator. Now let's go ahead and find each of them. So our first dimensionless group, let me write it down. First dimensionless group. So our first dimensionless group, let's call it pi1. So pi1 is gonna be the tau w, which is our numerator. On the candidate, we pick tau w first, and then over the power multiplication of the primary quantity. So let's say mu a1, u b1, or in this case, I wouldn't want to write b1, c1. I'm just gonna write a, b, d, c. Right? Just want to make sure. Yeah. So your goal is to find ABC, like an alphabet song, you know, find ABC. Okay, let's go ahead and do that. So you say, in order for pi1 to be dimensionless, you say the dimension of the denominator, the numerator, which is tau w, have to be equal to the dimension of the denominator, which is mu a b d c. So what is the dimensions of tau w expressed in terms of fundamental quantities or fundamental dimension? Like we demonstrated above, is m over lt squared, so equal to m over lt to power of a times that what's the dimension of so is L over t to power b times L to power c. L is the dimension of diameters d. All right, now we can rearrange and solve for a, b, and c. So here you write m times L to power -1 t to power -2 equal to m to power of a times L negative a t negative a L to the power of b t to the power negative b L to the power of c. Okay, let's go ahead and organize them. M negative 1 t to negative 2. So on the right hand side, I will group m, l, t together. So m to the power of a, so l to the power of negative a plus b plus c. Okay, I'm gonna keep track of that. Make sure this one already, this one already, this one already, and then t to the power of negative a minus b. Alright, so in order for two of them have to be equal, the power of each respective variable have to be equal. So you have 1 equal to a, so 1 equal to a, and then you have negative 1 equal to negative a plus b plus c. I'll highlight it so that y'all see negative 1 equal to this. And lastly but not least, you have negative 2 equal to negative a minus b. So let me do it in purple. Okay, and if you solve this is a tree equation, tree unknown equation, you get a equal 1, b equal 1, and c equal negative 1. Perfect. If you plug into the original dimensionless group, you get our first dimensionless loop pi 1 to be tau w to the power over mu times um times 1 over. Okay, so this is our first dimensionless group. Okay, so in the next video, I will help you find the rest 3. Stay tuned and see ya.